Hey guys, today we are going to discuss this problem. So as always, we are going to start with the example here. So in this problem, we are going to have two streams, and the first two numbers are the length of each two streams. So the first stream has 4 characters, and the second stream has 5 characters. And for each pair of the substreams of these two streams, we are going to calculate the score for them. For example, if we take the substream of the first stream as ABB, and the second stream as BAB, then the score will be 4 times LCS CD. The first stream is C and the second stream is D. And minus the length of C and the length of D, right? And the LCS denotes the length of the longest common subsequence of stream C. The longest common subsequence for this two stream is A, B, right? The common longest common subsequence is the for these two streams we delete some of the characters and we find the longest common subsequence, right? And for this CD, as the score of CD is 4 times 2 minus 3 minus 3, which is 2, right? So we are going to character the score of all of the substring pairs, right? And find out the maximal one and output it. So how can we solve this problem? We are going to use dynamic programming to solve this, right? And the formula is here. So we are going to denote dpij equals to the answer for the first I characters in the first string and the first j characters in the second string, right? And for example, if I equals to 3 and j equals to 4 here, then dp34 means we are going to calculate the final answer for ABB and BABA. So how do we calculate dp34? So we have two options. So when we calculate dp34, presumptively we are already calculated dp23, for example, right? We already calculate all the ij smaller than 3 and 4, right? Because usually when we do dynamic programming, we have two loops. The first loop is for I from 1 to n, right? And the second loop is for j equals 1 to m. So when we calculate 3 and 4, we already calculate um, all the values for dp2 and j, right? So So when we calculate dp3 and 4, we already calculated dp2, 3, right? And we already calculated dp3, 3, and already calculated dp2, 4, right? Because all these values, so we already one of the dimensions is smaller than 3 and 4, right? So we already calculated that. And what is these two options? The first option is that if the character in the first string at I position equals to the character in the second string at J position, then we are going to extend dp3, 4 from 2 and 3, right? We minus both of the dimensions by 1. So we are going to extend it from this value. So by extend, I mean we already calculated the final answer for 2 and 3. Now we are going to add one more character to the first stream and one more character to the second stream. And for the score, we are going to have longer longer LCS, right? So the length of LCS will be added by 1. So the final score will be added by 4. And the first stream's length is added by 1. So the final score will be minus by 1. And the length of the second stream is added by 1. So the final answer of the score will minus by 1. So in total, the final score will be added by 2, right? So that's why we have plus 2 in the formula, right? That's the first case where the last character of the first and the second string is the same. And the second option is that if they are not equal to, actually, no matter it equals to each other or not equal to each other, we're going to extend from these two values because for this one, we are the previous answer is for 2 streams. Let's say this is I minus 1 and this is I and this is J, right? So we are going to extend from this part because we already calculated the answer for this part. And we are going to add one character to the first stream. And this character will not match to any of the characters in the second string, right? So that why is that? Because if it um, matches the last character in the second stream or any of the character in the second stream, that case is already covered by, let's say it is this character, if the optimal answer is I match to T in the second stream, then this optimal case is already covered by dpi t, right? So in this case, we don't need to cover that case anymore. So let's say I is not going to pair with any of the characters in the second string. So um, we can extend dpij from dpi minus 1 and j, right? So in this case, it's extended from this value. And because we add one more character in the first string, so the final answer will be -1 because the score of LCS is the same, but the length of C is added by 1. So the final answer is -1. And so as the similar case where we extend the from dpij minus 1, right? Actually, the first case is extended by dpij minus 1, and the second case is extended from dpi minus 1j, right? And similar, we are going to minus 1 from this case as well. So this is where we get this formula, right? We minus 1 here because the first or the second stream is added by one character, right? So that's it. Let's look at the coding here. So it's extremely simple, right? So for the dynamic programming problems, the thinking process is a little complicated. It's hard to think um, the formula and the state, but the coding part is quite simple. So first we are going to read these two streams, and then we are going to calculate dpij, and here is a case where I character equals to j character, and we are going to use the formula here, and then we are going to extend from previous cases where the one of the streams is added by one character, and here is where we keep tracking of the final answer, and we are going to output the final answer in the end. So I guess that's it. Thank you for watching. Goodbye.